Exception No. 3 provides an alternative to ceiling penetrations when a building pressurization system and alarm system are in place. Your understanding of Exception No. 3 is correct. The building pressurization system must be maintained during operation. This ensures that the non-hazardous area remains at a higher pressure than the hazardous area, preventing the migration of hazardous gases or vapors. In the event of building pressure loss, the non-hazardous area shall be de-energized. This is a safety measure to isolate the hazardous area and prevent potential ignition sources. Or, a building pressurization system alarm must be installed and continuously monitored to signal loss of building pressurization. This allows personnel to take appropriate action, such as de-energizing the non-hazardous area or activating emergency ventilation systems. The alarm system must include a visual or audible alarm. This provides a clear indication of building pressure loss. It shall be the authority having jurisdiction to determine if the building power is to be removed. The authority having jurisdiction is responsible for assessing the specific conditions and determining the appropriate course of action. It is always a good practice to use a seal at the boundary when transitioning between area classifications. This provides an additional level of protection in the event that the alarm system is not installed or functioning properly. Building pressurization systems are engineered to maintain a positive pressure within a defined space relative to its surroundings. This is crucial in environments where hazardous materials are present because it prevents the ingress of flammable gases, vapors, dust, or fibers into the protected area. The system typically involves supplying air into the space at a rate sufficient to create a pressure differential, which can be measured in inches of water column. The specific pressure required depends on the application and the nature of the hazardous materials. Sensors and control systems are integrated to monitor the pressure and automatically adjust the FO to maintain the desired level. These systems often include redundant components and backup power supplies to ensure continuous operation. Air filtration is another important aspect of building pressurization systems. Filters are used to remove particulate matter and other contaminants from the incoming air, which helps to maintain a clean and safe environment within the pressurized space. The type of filter used depends on the specific contaminants that are present in the surrounding atmosphere. Regularly scheduled maintenance and inspections are essential for ensuring the continued effectiveness of building pressurization systems. This includes checking the filters, sensors, control systems, and airflow rate. Any issues that are identified must be addressed promptly to prevent system failures. Alarm systems are integral to the safe operation of pressurized spaces in hazardous locations. These systems are designed to provide an immediate alert in the event of a pressure loss, which could compromise the integrity of the protective barrier. The alarms can be visual, audible, or both, and they are often connected to a central monitoring system that can notify personnel remotely. The design and installation of alarm systems must comply with relevant safety standards and regulations. The location of the alarms should be carefully considered to ensure that they are easily visible and audible to personnel in the area. Regular testing and maintenance of the alarm systems are crucial to ensure that they are functioning properly. De-energizing non-hazardous areas in the event of a building pressure loss is a critical safety measure. This involves disconnecting the electrical power supply to equipment and devices in the non-hazardous area to eliminate potential ignition sources. The de-energization process can be manual or automatic, depending on the design of the system. Automatic de-energization systems typically use pressure sensors to detect a loss of pressure and trigger a relay that disconnects the power supply. Manual de-energization requires personnel to manually switch off the power supply. The specific procedures for de-energizing the non-hazardous area should be clearly documented and communicated to all personnel. The authority having jurisdiction plays a vital role in ensuring the safety of hazardous locations. The authority having jurisdiction is responsible for reviewing and approving the design, installation, and maintenance of building pressurization systems and alarm systems. The authority having jurisdiction also has the authority to conduct inspections and audits to verify compliance with safety standards and regulations. The authority having jurisdiction has the ultimate say in determining whether the building power should be removed in the event of a pressure loss. The authority having jurisdiction's decisions are based on a comprehensive assessment of the risks and potential consequences. Seals are physical barriers that are installed in conduit runs and other penetrations to prevent the passage of flammable gases, vapors, dust, or fibers. Seals are typically made of a non-combustible material and are designed to withstand the pressures and temperatures that may be encountered in a hazardous location. Seals are required in locations where electrical equipment is installed in hazardous areas to prevent explosions from propagating through the conduit system. The installation of seals must comply with relevant safety standards and regulations. The location of the seal should be carefully considered to ensure that they are effective in preventing the passage of hazardous materials. Firstly, seals are critical safety components. Secondly, seals prevent propagation of explosions. Thirdly, seals isolate hazardous areas. Fourthly, seals are required by code. Fifthly, seals use specific materials. Sixthly, seals need proper installation. Seventhly, seals require regular inspection. Eighthly, seals are part of a larger safety system. Ninthly, seals have different types. Tenthly, seals should protect electrical systems. Sealing fittings are used to prevent the passage of gases, vapors, or flames through conduit systems in hazardous locations. These fittings are designed to be filled with a sealing compound that hardens to form a gas-tight and flame-tight barrier. Sealing fittings are typically installed at the boundaries between hazardous and non-hazardous areas, as well as at specific intervals within hazardous areas. The selection and installation of sealing fittings must comply with applicable codes and standards, such as the National Electrical Code, often referred to as NEC, and those set by organizations such as the Institute of Electrical and Electronics Engineers, often referred to as IEE. The effectiveness of a sealing fitting depends on several factors, including the type of sealing compound used, the proper installation of the fitting, and the maintenance of the seal over time. Regular inspections should be conducted to ensure that the sealing compound is intact and that the fitting is free from damage. Explosion-proof enclosures are designed to contain an internal explosion without causing an external hazard. These enclosures are constructed of robust materials such as cast iron or aluminum and are designed to withstand high pressures. Explosion-proof enclosures are used to house electrical equipment that may produce arcs, sparks, or hot surfaces that could ignite flammable substances. The design and testing of explosion-proof enclosures must comply with rigorous standards, such as those set by Underwriters Laboratories, often referred to as UL, and the International Electrotechnical Commission, often referred to as IEC. The installation of explosion-proof enclosures must be performed by qualified personnel and must adhere to the manufacturer's instructions. Intrinsically safe systems are designed to limit the amount of electrical and thermal energy available in a hazardous location to a level that is below the ignition point of flammable substances. These systems use specially designed components and wiring techniques to ensure that the energy levels remain within safe limits. Intrinsically safe systems are often used in applications where it is not practical or feasible to use explosion-proof enclosures or other methods of protection. The design, installation, and maintenance of intrinsically safe systems must be performed by trained professionals and must comply with applicable codes and standards. Area classification is the process of identifying and classifying hazardous locations based on the likelihood of flammable substances being present. The NEC defines 3 classes of hazardous locations: Class I, Class Roman II, and Class Roman III. Class I locations are those where flammable gases or vapors are or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Class Roman II locations are those where combustible dusts are or may be present in the air in quantities sufficient to cause an explosion or fire. Class Roman III locations are those where ignitable fibers or materials are handled, manufactured, or used. Each class is further divided into divisions which indicate the probability of the hazardous material being present. Division 1 locations are those where the hazardous material is present under normal operating conditions. Division 2 locations are those where the hazardous material is present only under abnormal conditions. Understanding area classification is essential for selecting the appropriate electrical equipment and wiring methods for a hazardous location. Proper area classification helps to ensure the safety of personnel and property. The National Electrical Code is a widely adopted standard for the safe installation of electrical wiring and equipment in the United States. The NEC contains specific requirements for electrical installations in hazardous locations, including those related to sealing, explosion-proof enclosures, intrinsically safe systems, and area classification. Compliance with the NEC is essential for ensuring the safety of electrical installations in hazardous locations. The NEC is updated every 3 years to reflect changes in technology and best practices. It is important for electrical professionals to stay up to date on the latest version of the NEC. Proper grounding and bonding are critical for electrical safety in all locations, but they are especially important in hazardous locations. Grounding provides a path for fault current to flow back to the source, which helps to trip over current protection devices and prevent electrical shock hazards. Bonding connects all metal parts of an electrical system together to create a low impedance path for fault current. Proper grounding and bonding can help to prevent explosions and fires in hazardous locations. Regular inspections and testing of grounding and bonding systems are essential to ensure their continued effectiveness. Static electricity can be a significant ignition source in hazardous locations. Static electricity is generated when two materials are rubbed together, and the buildup of static charge can create a spark that can ignite flammable substances. To prevent static electricity hazards, it is important to ground all equipment and personnel in hazardous locations. Conductive footwear and clothing can also help to dissipate static charge. Humidity control can also be effective in reducing the buildup of static electricity. Hot work permits are required for any work that involves open flames, welding, cutting, or grinding in a hazardous location. Hot work permits are issued after a thorough inspection of the work area to ensure that all flammable substances have been removed or controlled. The permit specifies the precautions that must be taken to prevent fires and explosions. All personnel performing hot work must be trained in the proper procedures and safety precautions. Ventilation is essential for removing flammable gases, vapors, and dust from hazardous locations. Ventilation systems can be natural or mechanical, and they must be designed to provide adequate airflow to prevent the buildup of hazardous materials. The design of ventilation systems must consider the specific characteristics of the hazardous materials, as well as the size and configuration of the work area. Regular inspections and maintenance of ventilation systems are essential to ensure their continued effectiveness. Personal protective equipment is required for all personnel working in hazardous locations. Personal protective equipment includes items such as respirators, gloves, eye protection, and flame-resistant clothing. The type of personal protective equipment required depends on the specific hazards that are present in the work area. All personnel must be trained in the proper use and maintenance of personal protective equipment. Emergency shutdown systems are designed to quickly and safely shut down equipment and processes in the event of a hazardous condition. Emergency shutdown systems can be manual or automatic, and they must be designed to be reliable and effective. The design of emergency shutdown systems must consider the specific hazards that are present, as well as the potential consequences of a failure. Regular testing and maintenance of emergency shutdown systems are essential to ensure their continued effectiveness. Fire suppression systems are designed to automatically detect and suppress fires in hazardous locations. Fire suppression systems can use a variety of extinguishing agents such as water, foam, or dry chemicals. The type of fire suppression system used depends on the specific hazards that are present. Regular inspections and maintenance of fire suppression systems are essential to ensure their continued effectiveness. Hazardous waste management is the process of safely handling, storing, and disposing of hazardous materials. Hazardous waste must be properly labeled and stored in accordance with applicable regulations. Hazardous waste must be disposed of in a manner that prevents contamination of the environment. All personnel who handle hazardous waste must be trained in the proper procedures and safety precautions. Safety training is essential for all personnel working in hazardous locations. Safety training must cover topics such as area classification, electrical safety, fire prevention, and emergency response. Safety training must be conducted on a regular basis and must be documented. All personnel must be able to demonstrate their understanding of the safety procedures. Regular audits and inspections are essential for ensuring that safety procedures are being followed in hazardous locations. Audits and inspections should be conducted by qualified personnel and should cover all aspects of safety management. The findings of audits and inspections should be documented and used to improve safety performance. A management of change process is required for any changes to equipment, processes, or procedures in a hazardous location. The management of change process must include a review of the potential safety implications of the change. Change must be approved by qualified personnel before it is implemented. The implementation of the change must be carefully monitored to ensure that it is effective and safe. Incident investigation is the process of investigating any incidents that occur in a hazardous location. The purpose of incident investigation is to identify the root causes of the incident and to prevent similar incidents from occurring in the future. Incident investigations should be conducted by qualified personnel and should be documented. The findings of incident investigations should be used to improve safety performance. A safety culture is essential for creating a safe working environment in hazardous locations. A safety culture is a shared set of values, beliefs, and attitudes that promote safety. A strong safety culture is characterized by open communication, trust, and a commitment to safety at all levels of the organization. Creating a safety culture requires the active participation of all personnel. Remember that it is important to ensure that these systems are properly designed, installed, and maintained to guarantee their effectiveness.